Okay guys, so a lot of you have asked for me to do a Gen 3 build-a-base file for something that is a little more aggressive, that has a big camshaft, kind of what I would do, and just some of the standard modifications that you might see that a lot of folks are out there doing. So I'm just gonna go to my stock tune repository, and I'm gonna go with this 2005.3 stock file. This is gonna be pretty common with what a lot of people are still playing with, which I think is pretty relevant. If we go up here, it'll show us the operating system. It's P01, so I don't believe it's going to be flex fuel capable, which is fine. There's still a lot of great combinations out there that are Gen 3 that are really basic that still make really good power. So the combination that we're going to be dealing with today is we're going to assume that you are doing a bigger than stock motor. And you're going to be doing a bigger camshaft and a bigger throttle body, and it's going to be catless, and with so it's going to be for off-road use only, of course. And then it's also going to be we're going to add some electric fans, which is pretty common. So like the later 04, 5, 6, I think 05 and 6, 7 maybe, you could get the electric fans and the relays, and you just had to pin it into the ECM. And I'll tell you the injector part numbers that we're going to use, because we're going to do an upgrade to a Gen 4 injector that a lot of people like to do. We're going to go and assume that we're going to be using a 408 cubic inch motor. This could be applied to anything, though. You could be using, like my Yukon that you've seen on my channel is a 5.7. You could be using a 6.0, a 6.2, a 383, a 388, just whatever it is that you'd like to use. So cylinder volume, this is going to be a big one. So we need to make sure that we update this for the cubic inches that we are going to be using. So we're going to go up here and go to tools, and we're going to go to unit conversion. Down here under volume, cubic inches, we're going to say 408. That's going to be a 6.6 liter motor. Okay. What we're going to do from there is we're going to go back to tools and go to the calculator, and we're going to do 6.6, and we're going to divide that by 8, and that's going to equal 0.825. Okay, so we're going to go 0.825. That is going to update the tune file, for the correct cubic inch displacement that the motor is going to have. Okay, so that's going to be, we can check that off the list. Take my little pen here, check that off of my notes. That's going to be pretty important. Okay, have to have that. Next, we're going to go under idle. Okay, and by the way, over here in general, all this stuff, you don't need to mess with any of this. None of this at all. Firing order, the air pump, you don't need to mess with any of that. Just cylinder volume. That's it. Okay. We're going to go to idle. This is a big one. Okay. You have the RPM and the airflow tab. This deal right here, the adaptive idle, this PID system, you do not need to mess with this. Some people do. I personally don't. I haven't really found the need for it yet. But this base set point, this is going to be our base idle. Okay. So we're going to assume that we are using pretty popular camshaft here, the BTR Gen 3 and 4 Stage 4 V2 truck cam. You could apply this to one of the Texas Speed ones, the Torquer 2, the Torquer 4, the TSP 228, which is what's in my truck. Truck Norris and Chopacabra is going to be a little bit smaller than this. What we're really after, though, is that right there, the lobe separation angle, that's going to be pretty aggressive, which is good because it's going to make great torque down low. Pay attention to that, as well as this right here. Okay, so if you're going to do a cam this size, you're going to have a converter. Which if you're going to pull the motor out and do something like a 408 or a 388, you should be doing that anyway. You should most definitely do a converter. At least of 2800 or better, preferably more, like a 32. If you're going to be in there and spend the money, you might as well do it. This is a pretty popular camshaft, especially amongst the 5.3s, and this is honestly too big for the 5.3s in my opinion. But we can go here. I'm going to probably go and just command at temperature 219. We're seeing like 575, 540. We're just going to say 200 more. So we're going to go 200 plus, and we're going to start there. Especially on like a new build, you're going to want to just get the thing up and running. Okay, so we're going to be commanding a more idle. We're also going to need more airflow. Okay, so I'm going to come under here under the airflow tab. Base rating airflow. This is going to be way too little airflow though. Okay, so what I'm probably going to do is I'm going to come here around 140, and I know that I need to be somewhere like in the 11 or the 12. So I'm probably just going to go in here and I'm going to add 6, something like this. And then I might do a left to right interpolation, something like that. That probably would be okay for right now. You might find that when you put it in park or neutral, you may have to go in and add like 1 gram of air. Okay. Well, you can notice here we're in grams per second. You can pick the units that you want to work in. I like grams per second. Half a gram of air is a pretty good bit. So, as opposed to pounds per hour. So that's just something to keep in mind. But definitely with the idle and this table, you're going to want to do that. That's going to be pretty important. Okay. The rest of this, all of this, you can pretty much leave alone. Same thing with here. Over here, the startup airflow, we may want to go in here and just set this all to like 7.9, and that's in pounds per hour. So it's not nearly as much as grams per second, but you would definitely, want to add a little bit more here. It's going to need it on fire up, so that's just something to consider. Let's see. Sometimes friction airflow, maybe you need a little bit more. For right now, probably not. We'll just let it kind of see what it's going to do. We're also going to assume throttle follower. Don't need to touch that. You could go here to the decay, and if it's decaying too fast or too slow, if you hover over it, you notice where it says down here, hence higher the numbers mean faster decay. You could cut this in half if it's decaying too fast and it's stalling. You could go in here and just hit 0.5 and then hit multiply. You could do something like that if it's decaying too fast. But for right now, we're assuming we have a brand new motor. We're just trying to get this deal up and running. We're going to also assume that we have a 90 millimeter throttle body. So whether you are using a rec port head with a rec port truck intake manifold and a 4-bolt 90 millimeter throttle body, or you're using a cathedral port head and intake manifold and you're just adapting the throttle body, what you would want to do here is take this number, what is this, 0.0255. We're going to go over to tools and we're going to say, actually, no, we're going to leave this alone. 78 millimeter stock Gen 3 throttle body to a 90 millimeter is not very big, so we're actually not going to touch that. We're going to leave that just like it is. Throttle cracker and follower, you can go in ahead and update this. I like to go in here and do something like this. That way we don't have any hanging idle, and just kind of cascade this with 0 so that it soft lands kind of deal. You don't have to do this. You can. This table usually throws people for a fit. I don't recommend disabling it and what I mean by that is coming down here and setting these both to like 256. I don't recommend that. I would say just leaving them at 3 is fine. What I might do is set this to like 9. Oops, sorry. Wrong order. 9. There we go. You can see here the enable speed, throttle cracker enable speed. Above the speed, the throttle cracker is enabled and the adaptive idle routines are immediately disabled. That means that everything above 10 miles an hour, throttle cracker is going to handle, and everything below 9 miles an hour, the adaptive idle is going to handle, which the adaptive idle does pretty well, so you should be okay there. We're going to go over here to airflow. Primary and secondary. Has this already been? I haven't touched this. Okay. So what you can do here, just to get it running, you can leave it in its blended mode. There's your mass airflow frequency table. You can leave this like it is. If you want to go in here at 8,000 and you can add, I don't know, 0.7 or 0.05, 0.07 or 0.05, which is what a lot of people will tell you to do to get it to the tuning shop. You can do that. Smooth that out. That way it's nice and smooth. You can do that. That way it gives you a little bit more fuel up top. It's up to you. The VE table, wouldn't touch it. Just leave it alone. We can talk later about mass airflow tuning versus speed density. For right now, you can see that under the airflow dynamic tab that the higher RPM disable is 4,000. That means technically anything above 4,000 is the mass airflow, is on the mass airflow table. Everything below is speed density, but really anything that's transient. So when you stand on the throttle, when you shut it down, so on and so forth. But for right now, we're just gonna leave this like it is, okay? And then we have the electronic throttle. We're not gonna touch that. Exhaust, don't need to touch that. Fuel, we're going to assume, if we see here, 0 kPa, we have a 24, basically a 24-pound injector. We're going to update this. So we're going to go to our injector data tab, and we want to use the popular 1261-3412 50-pound flex injector. You can get this online. Some people sell it, or you can also email me or let me know and I can get it for you. This is what it came in. So if you had an HPTuners stock file, this is what you would use. There's two different types you got here. You've got the top, which is the returnless or the deadheaded system, okay? And then you've got what a lot of us have, which is the return style, okay? And so this is what we would use. And so here's your flow rate versus kPa. So we want to go in here and copy this. Copy, go back here, flow rate versus kPa. Go in here and hit paste. Go back to our spreadsheet, and then we have the, make sure the axes are going to be are going to be correct. There's 0 to 80, and then 4.5 to 18 or 18.5, whatever it is. This is the offset versus volts versus vacuum. So we're going to take this, and we're going to hit copy. Offset versus volts versus vacuum. Right click, we're going to hit paste. There's that. What's the next table? If short pulse limit is 3997, which it already is. And then we have the short pulse adder. Let's go over here. This goes all the way out to 4. Right click. This is the short pulse adder, and you can see that it goes, make sure the axes are all the same. Go over here and hit paste. It's going to change that. This part is minimum injector pulse width. This is incredibly important. If you mess this part up, you're going to have a vehicle that does not run worth a flip. Minimum injector pulse. Go here to paste. Sets that up. And then there's one more, which is the default injector pulse. And we'll copy this. Go back. Here we go. Default injector pulse. Paste. There you go. So we are set up for the 1261-3412 flex injectors, 50-pound flex injectors there again. This is what they came out of. If you want this, just let me know and I can get it to you. Okay. So in the fuel general tab, we're all good there. Oxygen sensors, we can go in here to long-term fuel trims. We can disable these, select disable, set our min to 400, set our max to 1, and set the min kPa to 255. That will cancel them out. Open loop base, you want to make sure short-term fuel trim open loop is disabled. We don't need any data from the short-term fuel trims while we're in open loop. That's what the wideband sensor is for. EQ ratio, if you wanted to set everything at like 104 and above to 1, you could. We're not going to right now. There's just no need to. Power enrich. We're going to say the minimum kPa is going to be 65. This is definitely way too high, so we're going to go in here to our throttle trigger, hit that to 60. Everything 4800 and above we can set to like 15, and then we can interpolate them over. That way, and we'll copy this, put this in the cold table. The cold table is the one that is referenced. Oops. Oh no, I didn't get it copied. Whoops. Try that again. Right click, copy, cold. There we go. That'll work. Yeah, you can see here the hot select's 251, so you're always going to be referencing the cold. Minimum RPM delay, we can set that to something like 1,000. EQ ratio gas, this is your wide open throttle fueling. If we want to command like a 14.7, sorry, we want to command like a 12.5 at wide open throttle. So if we go 14.7 and we divide that by 12.5, 1.176 is where we want to be for our multiplier. We'll just set this whole table to 1.176. That way we're not shooting for a moving target. So temperature control, we're catless, so we're going to disable this. Fuel decel cutoff, not going to turn that off. It's fine just like it is. The rev limiters, we're going to leave that like it is for right now. That's probably okay. We could bring it up some, but for this application, we'll probably be just fine. Okay. And then if we go into the Spark Advance and we go to base, fuel base, we want to zero all this out. We want all of our values coming from our high octane table. If we go to the IAT base, I may do something like this, zero this guy out, and then 131 and above, we can interpolate. That way, you know, if you're in the summer and you're sitting around, it's not going to get super hot and super crazy and try to pull a bunch of timing out. Here, we have engine coolant temperature on this side and cylinder air mass on this side. So, engine coolant temperature, 212-ish is about running temperature. So, I want to go here and zero this out, and then we can take 212 and above and kind of do like a little interpolation there. We don't really need this. We can get rid of that. On some of the later model ones, like the P59 03 to 06 trucks, it might be inverted, so these axes would be different, but it's the same concept. So if you're 212 is pretty much running temperature, so you don't really want to be pulling any timing there, but everything above that, you can start to yank some timing out of it. EGR, we don't have that. So we should get rid of it. None of this other stuff is going to really matter. These in-drive and in-park tables, leave them like they are. This is enough timing for a cam like this. You should be just fine. High octane table, the stock modeling is going to be pretty good. So until you get a wideband sensor in it and you start getting your fueling lined out, this is going to be just fine. I wouldn't worry about this. These values aren't going to be overly aggressive. They're probably going to be, even though we're commanding a little bit leaner mixture, they're probably still going to be just a little, little mild. So overspeed and underspeed tables, no need to do that. If you want a cam sound, get you a camshaft that does cam stuff. Let's see. Spark retard, recovery, we might go in here and multiply this by like 2. That way, if you do get any knock, that it recovers quickly. So we might do something like that. Burst knock. You'd have to log this, but probably just leave this alone for right now. I wouldn't really touch that. Knock sensors, I wouldn't mess with any of that. You're going to be just fine there. Torque model or general, no need to mess with that. Torque loss, probably not going to mess with this. Maybe if you have a really big cam and the AC is struggling, you can mess with it, but I probably wouldn't. Okay. RPM versus gear, this looks like it's already maxed out, which is good. This max torque, you can see down here at the bottom, 640 is the limit. We can just go ahead and change that. It's not going to hurt anything. TPS max, we're not going to use this as a drive-by cable. I'm not going to touch torque management stuff there. This spark retard versus torque reduction, you could cut this in half if you wanted to. That way you can still drive in the rain. Same thing with the torque loss. You could cut this in half, and that would be okay. Traction control, there again, we can cut this in half. It's probably going to be just fine. It's not going to hurt anything. Most people just turn it off, I'll be honest with you. Drivetrain abuse, probably set that to like 8,000. That way, you can see here, drivetrain abuse, enable RPM. RPM must be greater than this to enable the drivetrain abuse calculations. So basically, everything under that, drivetrain abuse can't be enabled, which is just fine. And that's going to kind of take care of that part of it. We're going to assume airflow. We're going to assume we're still using a mass airflow sensor. That'd probably be fine. We can go in here to the P1514 table and set this to like 410. It's a pretty standard number. Never going to reach that. Just wanting to make sure. Same thing with this mass SIL air deal. Put that at like 410. It's going to be just fine. Misfire with a cam, you probably want to come in here. I wouldn't just set these all to like 32,767, but with a cam, you probably want to come in here and multiply these by like 2. That way, you know, you're going to have probably some misfire counters because of the camshaft, but if you go in and multiply these by 2 and then maybe like a half at a time, you can still retain the misfire, you know, counter, which is okay. If you just set these values to their max, and obviously this thing could be running like crap and it would never throw a check engine light. DTCs, anything that is a O2 banked sensor 2, you would want to go in here and set this to no error reported. So anything that is sensor 2, okay? So I wouldn't uncheck them. I would just change them to no error reported. So you can go through and check these out. There's even a sensor 3, which hasn't even been used there again, so on and so forth. So if we go over to trans, we're not really covering that right now. Trans diag, fuel system, no need to touch that. System, general, if it's a swap vehicle, you would want to set this to none, the VATs, and then do a right entire. Fans, we're going to go ahead and say that we are using 2 fans, but these on and off switches are not very good. So we're going to go to open compare, and we want to go to like a manual, like a vet. Okay, come over here and we can see the differences, and you could copy these all over if you wanted to. The on and off ECT is what I'm most concerned with. So I'm going to go over here and do something like this. And then same thing with the running condition. I'd probably do something like that. So that would be a good route to go, at least to get started. You could kind of leave this deal like it is. No need to really mess with that. Let's see here. You could probably go to, let's see, what was that on? Fan 2 and analog. You could set this to fan number 2 and analog. That'd probably be okay. You can leave your disable conditions the way that they are, although I would probably set these to like 4,000 and maybe 3,900, and then my disable to 80, my enable to 70. That would probably be more than fine. Your speedo, we can do that in a different video, the tires and all that stuff. The limiter, you can let your speed limiter be 120, something like that. That'd probably be fine. Again, 120. So that's going to be kind of a good starting point for a big cam combination. So yeah, if you have any questions or anything, feel free to comment down below, and yeah, we can go from there. Thanks for watching.